Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to kick off a small series talking about reverse engineering this airbox that we have in Fusion. So some of our more popular videos are about doing reverse engineering, or at least reverse engineering on car parts. I have to give a disclaimer before we get started that programs like Quick Surface, which we are an affiliate for on this channel, are much easier and more equipped to do this kind of job. Now, we've done it in Fusion with plenty of other designs, and for this one, we are going to go ahead and do it in Fusion. I will note that we're going to do this in a couple of different parts, meaning we're going to do a few different videos. There are lots of different topics, and I think generally the biggest question or the most important question I get when looking at a design like this is, how do we get started? How do we actually create the base shape or the base sort of geometry of this? So in this first video, we're going to focus on that, how we get started and create the base shape, and also some topics for things like creating planes from the reference mesh and things like that. So first video, we'll do some big sort of geometry creation. And then in following videos, we'll focus more on details and creating the final parts. Now, I don't know what car this is off of. This was sent to me and the user was nice enough to allow us to share it. So if you want to follow along, I put a link in the description of the video. You can open up the Fusion file where it's already aligned to the coordinate system. I did that, of course, in Quick Surface. And when we look at the shape, you'll also notice that this is a pretty low polygon mesh, so I reduced it quite a bit from the original scan. And the first step for me is always going to be right click and make it unselectable. So this will help with the performance because every time you hover or move the cursor over a mesh, if it is selectable, then Fusion has to basically do this highlight on every single triangle on the mesh body. Now, even when we're not in direct modeling mode, we can't select individual vertices, but it still has to highlight everything. So this version, if we go to properties and we take a look at the mesh information, we're down to a little bit over 100,000 triangles, 100,000 facets. Originally, this was in the millions, so it really does bog down the system. So first step, again, is always taking the scan data. This, I believe, was done with the Scan Raptor. And that's making sure that it's aligned to a coordinate system and that it is a low version, a low polygon count version if you're going to be working with it in Fusion. If you're sticking with a mesh program like Quick Surface, then they handle larger meshes much better. But again, it's just kind of a first step. The second step that I look at with something like this, there's a lot of detail, right? There are a lot of different features. There are things like, I'm going to assume this is for like a mass airflow sensor. There are pieces for, this is probably a vent hose or, a big vent line go to, I don't know, it's charcoal canister, depending on when this car was made. And so you can see there's another one back here. And then there's some features where it is going to be pressing down on the lip of an air filter and maybe locking into some other geometry. So there's going to be a lot of these little features that we're going to have to look at creating. Not all of them are going to have quite the level of detail just based on the scan. Some of it is from doing a lower polygon version. Some of it is just from the fact that scanning stuff like this, you're not always going to get a perfect representation, especially scanning into the inside. So our final model is likely not going to have every single feature, but we're going to cover all the big ones so that you'll have at least some confidence in doing that yourself. Again, another note here, this is a injection molded part, as most plastic parts on cars are, which means that the way that some of these features were designed were specifically to keep a consistent wall thickness. So for example, these little pieces on the backside, you can see they have these recesses, and those are really there because for this geometry to work in an injection molded environment, it needs to be consistent wall thickness. So it had to be this wide, but it couldn't just be solid plastic. So they have structural ribs where they can, and then this section here probably goes all the way down to this face, and it's just kind of filled in from the scan. These areas where I would assume a large sort of rubber vacuum hose goes, you can see they are recessed here, again, to keep that consistent wall thickness where they can. So keep in mind with some of these features, depending on the end goal, if it's 3D printing or some other manufacturing method, we don't have to really recreate everything perfectly. You certainly can. We'll talk about that maybe with one of these parts, but we're not going to go through the entire process to make this a injection molded part. Okay, all that out of the way, now that we're all on the same page, let's get started creating the basic shape. Now, the first thing that I look at with a complex part is I try really hard to visualize this with all these extra little pieces missing. So at the core of this, I'm just going to do a basic sketch so we can kind of get an idea of this. But at the core of this, and I'll use a spline for this example, don't follow along just yet. But at the core of this, we've got a straight line coming up, and if we kind of follow along, there's a straight line sort of here, and as we come down, essentially straight right there. So if we take away the airbox, that's the shape that we get from that side view. I'm going to do Control Z and undo because I don't need that sketch. The other thing that we need to look at is from, let's say, a right view. Just like when we're trying to do complex curves for modeling a car, I try to look at everything from a 2D perspective with two different viewpoints. So from the side, we have a very clear sort of section view. From the front and back here, or left and right as the view cube is, it's not quite as simple. So for example, again, if we just do a basic sketch, this is the rough shape that we've got here. And then if we do, let's say, a fillet on this corner, that gets us pretty close to that shape, right? It's not perfect, but it's pretty close. Now, the problem with this is as it goes backwards, so I'm going to extrude this just so we can kind of see it. But at the front, it matches. This is kind of the view that we were looking at it from. But at the back, it doesn't match. So you can kind of see it tapers away here. So the way that we're going to have to approach this may be a little bit different. Again, all of these decisions come down to what the end goal is for this design. Now, the taper on this, if we kind of go and I'm going to delete that sketch, but if we look at this and we think about it from a functional standpoint, it's tapered backwards, most likely because of the angle of the intake here, right? So this is going to be, it's not going to be a cold intake by factory. It probably goes into the fender or into somewhere else to get air to the airbox. But essentially, this is tapered backwards because this is at an angle. It could have been done from a performance standpoint, could have been done simply based on space available. This maybe had to be tilted up 10, 15 degrees. I don't really know. So with geometry like that, we have to take a second and think, is that important to the design? Do we need to taper it backwards? And if so, how do we achieve that? It's not going to be as simple as just extruding that curve backwards with a taper because the sides down here are straight. So a couple ways that we could approach a shape like this is to create several sketch curves and loft them, or we can take a simple approach and maybe use some direct modeling tools. So that's the approach that I'm going to take. So the first way that we're going to do this is I'm going to look at it from the side, and I want to think about, again, this basic shape. If we want to extract that data, we can do so with a mesh section sketch. We select the mesh body we're interested in. It's unselectable, so we have to do it over here in the browser. We need to pick the section plane, and for this, I'm going to have to rotate it. It gets tricky because we need to find somewhere that we've got basically a clean cut through it, which is not really going to happen anywhere. This is probably the best that we can get. And then we're going to say, okay, I'm going to hide the mesh. And now you can kind of see what we're working with. There's a straight face here, but it kind of picks up back down here. So if we want to work with this, we're going to go to our sketch. We're going to edit the sketch. And now we can use fit curves to mesh section sketch if we want. Now, generally, this is an okay idea. However, with things like this, what I would say is you don't want to use a spline curve. And the reason for that is if I do a spline curve right here, for example, I'll say okay, and I'll take a look at the curvature on it. Even though that's a fairly consistent arc, and just bump the scale up a little bit, even though it's a fairly consistent arc, that is a lot of variation. And the reason for this is because when we do a fit curve to mesh, especially with something like a spline, it has to work within this tolerance factor. So if we take this tolerance factor to say 0.1 instead of 0.01, and I say okay, and I look at this spline, By changing that tolerance factor, now I'm getting a much smoother curve, but you can still see there's like this step that happens in it. And again, the reason for this is because at the core of this, what we're looking at is a bunch of little flat triangles. And so to try to fit a curve or a mesh to that means that we're going to have some of those irregularities in here. So in general, I will not use a spline in a mesh section sketch unless I have a very good reason to. As a reference would be okay. But it is pretty good with doing things like straight lines. So for example, if we wanted a straight line from there to there as a reference, I'm going to right click and repeat that. I'm going to do maybe a straight line here, right click and repeat that. And the reason I'm doing a right click and repeat is because if I carry on, it's going to keep making straight lines because it's looking for a second point in the selection. And if you clear this off, you can start a new one. But just kind of my habit of the way that I work is generally I use this right click marking menu. And so like I'll create a line here and I'll just right click and slide up. So basically at 12 o'clock position, and it'll start the tool again. So that's just the way that I tend to work. You can certainly do it within the menu and clear out your selection. But the reason that we have this is basically we've got a straight line section here, and we've got some straight line sections here. So the way that I am going to kind of work this is I'm going to go from the origin. I'm just going to kind of draw this horizontal line as my reference. And when I align this, I didn't put the origin at the center of the part. There wasn't really a very clear center, so I just put it at this corner. But if you're wondering why it's not perfectly centered, that's why. And then up here, I'm going to hit escape to get off my line tool. And essentially what I want to do is just going to drag this out. I'm going to drag this one out. And all I'm doing is visually making sure that it's right. Now, this is not a perfect solution. Again, when we think about this with something like Fusion, we are not going to be creating a high quality reverse engineered part that is really close in tolerance to the original part. And it's because we don't have any analysis tools. We don't really know how close we're getting. But I do know that I've got a pretty rough approximation of that straight line. Got a pretty rough approximation of that one. I'm going to say that this one is vertical. I'm going to hit escape to get off my constraint tool and just kind of drag it over. And then with these sort of overlapping sections, I'll just use my trim tool and drag it through over here. So nothing is snapped to the mesh right now. It is just all sort of just built. The next thing I'm going to do is I'll kind of block this off. And then over here, I'm going to leave this extra section. All I need is the profile. And I don't want to break this because then it'll mess up the constraint on the bottom. So I can just have that little extra hanging out there. And then we can do a fillet in here and take a look and see how close this gets us. So you can see that at about 65 millimeters, that actually looks pretty close. If we go a little bit more, it seems to be too big. So 65 looks pretty good. Over here, 65 appears to match that side as well. So I'm going to right click and say OK. So if we hide the mesh section, I think that's a pretty good approximation of the shape of our airbox. Now, is it perfect? No, because we don't really have a great reference. Right here, we've got this flat section, so we kind of have to assume what's happening. If we came over here, we would be missing some of the top data. So it's a great first starting point. From here, I'm going to go to extrude, and I'm going to pull this out until it's bigger than the airbox on that side. We'll say two sides and come this way, and kind of look at where the mesh is coming through. You can see it looks like it's coming through in the middle. We'll say OK. If we hide that body, the reason it's falling away here is because things are rounding off. So I think this is a great first step. Kind of looks like a mailbox, but this is giving us the starting point for our rough shape. The second thing we need to do is repeat that for this other direction. So once again, if we want to, we can create a mesh section sketch. We'll select the body again from the browser over there, pull this back until it's where we think it should be. This is, again, this one's going to be a little bit trickier because in reality, what I think is probably the best case is just to do it visually. So I'm going to hit cancel. I'm just going to create a regular sketch. Knowing that we are not creating a perfect 100% exact replica because we're not going to be able to analyze it. I'm just going to create some lines coming from the origin, make them out. And then from there, I'm going to go up vertically, come over horizontally, and back down vertically. So we'll make this line vertical and just drag it over. You can see there is a taper to it. Again, this is an injection molded part, so it is going to have draft on it. If it's textured, probably has 5 degrees of draft. For me, however, I don't think that it's really worth the effort to make it like that. So we've got this profile. We can add the fillets here in the sketch. It might be easier to not do that. So what we're going to do is we're just going to say finish sketch, and we're going to extrude this. So we're going to come all the way through the front of it, and we'll say okay. So you might be thinking, okay, well, it's obviously not the right shape, but we can't really do a loft because then these sides aren't going to be parallel anymore. And then if we try to taper it or like extrude it with a taper, then again, we kind of have that same problem. So what we're going to do is a little bit of direct modeling. I'm going to right click on the body, change its opacity to something a little bit lower so I can see inside of the design and kind of look where we're at. All right, so remember from the side, we've got this shape. So that's going to define everything that we see in this direction. So really all we have to worry about is kind of matching it from here. And there are two kind of defining factors here. So the first step, or the first thing I think we should do is just create some fillets on the side of this, do our intersection, basically use our Boolean operations, and see how close we are. And then if we're not close, we'll kind of step back and then go from there. So first step for me is I'm going to go ahead and fillet these corners. So I'm going to grab that one and this one, and then just kind of pull them down. And it looks like about 60 is going to work here. Okay. So we've got this shape front to back, and we've got this shape side to side. So I'm going to get started by going to combine. We're going to do an intersect, which is going to keep only the overlapping sections. Target body, I'm going to use that first extrude and the second extrude, and we'll say okay. And then just take a look at our results. All right, so you can see front to back, it's matching there. Going to right click and change the opacity down so we can kind of see what we're working with. And then we've got basically these corners are a bit far away, and fillets may take care of it, but they also may not. So in order to validate that, let's start by adding some fillets and just start dragging it in. Look at it from the top. And basically what I'm looking for is to see how close I can get this to match. And it looks like maybe 25 might be relatively close. I'm going to hold down Control and add it over there. We'll say okay. Go back to our opacity, set it back to 100%. And that's relatively close. So as we rotate around, one thing you'll notice is you may start to see more of the mesh and less of the mesh. So it's kind of coming through. That means they're really close. The fillets in the corners are not perfect. We definitely are closer up front than we are in the back here. And I'm going to go to Inspect and Display Mesh Face Groups. That'll just change the color of the mesh face group based on its component. And go back to the body here, change opacity, and I'm going to set it a bit higher, like 60%, and then just kind of see where the gaps are. All right, so you can see, because we didn't taper that top body backwards, this fillet, there's a little bit more material right there. So it really does need to taper backwards. And then the other side, it's kind of the same thing. It needs to taper backwards. All right, so if you run into this, this is a decision point. We have to think, okay, well, is it really important that we taper that back? And if it is really important, then how do we do it? So first thing I'm going to do is I'm going to save this because I haven't saved it at all. And then I'm going to delete the fillet, delete the combine, hide body one, and I'm going to focus on trying to taper that backwards. So one sort of interesting aspect of this is, again, this bottom section here is essentially, this bottom line here, at least to me, it looks like it's essentially staying parallel. And the the change is happening up here. So it's kind of tapering inward. So when I look at a shape like this, I have a couple of thoughts that come to mind. One is to split up this bottom section and everything above the sort of these fillets or arcs in and work with the bottom section and then build the top from there. The other thing that we can do is to try to cut away some geometry. That's a little bit harder to do. It's a little bit harder to visualize and kind of figure out. So anytime you have a complex shape, breaking it into multiple parts can often be a pretty good way to work at it. So what we're going to do is I'm going to start by creating an offset plane. I'm going to start at the bottom here. I'm going to set this to object and just click on one of these corner points where the fillet starts. So what this is going to give me is a feature, or in this case, a plane that I can use to split the body. So I'm going to say split body, and I'm going to split it with that plane. The reason that we do this is because now we've got this top section that we can kind of hide and get rid of for right now, and this bottom section. So the bottom section is important, and now we can change the opacity, go back to 100%. The top section is important here because now we can kind of see that it's curved here and it's sort of tapering away. Don't worry about that little cutaway section here. Actually, let's look it over here. So it's not perfectly flat. Of course, we know that it's an injection molded part. Everything's going to be pretty much a curved face for the most part. But we can see that it's kind of tapering away as we get back here. And then if we look at this at the bottom, I'm going to try to let's do a section analysis. And it's probably not going to help us too much. But what I was hoping to see is whether or not the bottom did truly stay planar. And it's not really very easy to see. Let's go down just a little bit. Let's go to minus 3.5. No, let's try minus 2.5. So what I'm trying to see here is whether or not this bottom edge is truly linear, or like I'm assuming it's linear. You can see it's poking out just a little bit in the middle, which means it is bulging. It's got a little curve to it. But essentially, I think that leaving this bottom edge straight is kind of what we want to do. So I'm going to cancel the section analysis. So what I have to do is figure out a way to get the shape to taper up here, but stay this shape at the bottom. And I'm going to do this with a loft. So the easiest thing for me to do is just, let's hide the construction plane, but start a new sketch on this face. And let's rotate it around. And again, I'm going to assume, in this case, that we're working with linear edges, even though in reality I know that this is curved. But what I'm going to do is create a line, goes from here and comes back, and basically what I'm trying to do is create that taper. I'm going to do the same thing over here, and then I'm going to use my dimension tool, which is D on the keyboard, and let's give this a 1.5 degree angle. We'll do the same thing over here and just click on this so they're the same, and then hit escape, and I want to connect that and this. Now, you might be thinking, why did you do that? You don't really need to. In reality, I don't, but I like to convert these to construction. The edges I don't need are the edges that don't have that coincident relationship in the corner. And mainly because sometimes you'll find that profiles can be finicky, especially if you decide to come back and change them. I don't want to give Fusion any other possible scenario other than this one single profile. All right, so now that we've got that, hide the mesh. And what we're going to do is we're going to loft from the bottom. So select loft. We're going to go from this bottom profile to this top profile. So it's going to leave the bottom edge linear, and it's going to taper in to this top edge. Now, I'm going to use the option for intersect. I only need to keep the overlapping parts. I could also just create a new body. The reason I'm using intersect is because it'll automatically get rid of the original body as well. So I say okay, and I don't have an extra body there. Now, the downside to this is that top piece, which let's go ahead and make the opacity 100% again. That top piece no longer matches. So now I need a top piece that we can basically add these fillets to. So the way that we're going to approach that is we're going to extrude. So here's a little trick or a tip. If we select extrude and we select this face, we can pull this up and it'll add to it. and then we can bring back this other body and we can essentially say, go up to this face. So this allows us to extrude or add the geometry to this. The downside to this is that we won't actually be able to carry that angle. So it's basically a straight line up front of plane on the front of this thing. And then this angle is going from tapering in to going straight up. So this is one way that we could do it, but then we're going to have to, again, sort of do a loft and kind of cut things away. So the way that I'm going to approach it, I'm going to hit cancel. The way that I'm going to approach is I'm going to take this design, select this fillet and hit delete. Actually, no, it's not going to let me do that. Because it won't let me do that, I am going to do something different. We're going to go to surface. I'm going to say offset, and I'm just going to turn off chain selection and just take this top face here and say okay. And we'll see why in just a second. Now, the reason I want to do that is because now I can go in and say ruled surface. From this edge, we're going to go tangent, and now I can pull this up. And so what this is going to do is it's going to allow me to basically extend it out past. We're going to right click and say okay. I can repeat that. So basically I can take these edges. Notice if I grab both of them, it's kind of overlapping in the center. If I do mitered corners, it'll take care of that. So this tells me I can go back to this original ruled surface, hold down Control, select these edges, and miter the corners. Actually, while we're at it, let's go ahead and grab the front one as well. We'll just do all of them. Go crazy. All right, so now what I have is basically this box. If this was a plane, I could create a solid body here. Since it's not a plane, I either need to create a plane or extend this out until it overlaps with this geometry. We can try it. Let's go ahead and give it a try. I'm going to do boundary fill. So I'll select this is a tool, this is a tool, this is a tool, and it doesn't work. So if this is a plane, it would work fine. When you cancel the boundary tool, it goes a little crazy with the colors for some reason. So sometimes you just have to hide them and show them again. But what I'm going to do is hit extend. We'll grab both of these and just extend them until it overlaps. You can do the same thing with this edge too, or in the entire thing if you're worried about it overlapping. And then on the bottom, what I'm going to do is let's delete that face. So now I've got a surface, and basically now I've got these three surfaces I want to combine into a solid. So boundary fill, bottom surface, this ruled surface, and this one. We'll go to cells, click that. We're going to make a new body. And then when we hide the surfaces, we're left with a solid body where these faces now have tangency. I'm going to go back to my solids. I'm going to select this face and hit delete. I'm going to do the same thing over here. All I did there was patch the surface. The reason I don't want an edge there is because once we add the fillet to that corner, what's going to end up happening is if those edges get really close, it just gets messy. So it's more features in the timeline, which generally I hate, but it is a little bit nicer and cleaner. All right, so we need to check what we've got going on here. So we're going to add a fillet. We may need to taper this top section, but I'm going to leave that in just a minute. I think we were at 60. Let's say okay. And then we're going to combine these two. All right, and then we'll add a fillet. So F on the keyboard. I think this was 25. Let's go a little bit bigger and let's just see where we're at. All right. So we're fairly close. Again, there's a curve on the back wall. They're not actually planar, so we're only going to be but so close. We're going to go ahead and change the opacity. All right. So it looks like we're still maybe a little bit off, but not very far. So what this tells me is I potentially need to do a little bit more tweaking or messing around with those shapes. I'm going to show you a couple of tips that we can do for that, but I don't really want to spend a ton of time doing it. But what we can do is we can try to use tools like move face. We'll just change this to be faces. We're going to select this face from the front edge. And then as we rotate this down, so you can see that it's allowing it to taper. It's probably not a full 5 degrees 2, maybe 3 degrees might get it. And then if we go back to the combine and then this fillet, doesn't like it now, just needed a rebuild. So you can see that we're getting closer and closer. We're seeing more of the mesh right here on those corners. If we go back to our opacity and we look, you can see that we're getting closer and closer to that fillet. It's not perfect, and it's never going to be with straight lines, because you can see that we're, it might be hard to tell, but you can see we're close in the middle, it overlaps, and then we get a little bit of a gap here. And that's simply because that back face is an arc and it's not a straight line. So there is not a situation where we're going to perfectly match with this method, because it is an injection molded part. Also, it's a part that was in use, so the chance of it being perfect, in original condition is very slim. But hopefully now you can see just a couple of different ways that we can try to get to that geometry. So I'm going to call that good for getting the base shape, or at least that starting point. I want to take some of these other bodies here, so I'm just going to shift select all these, right click, and remove them. So again, it adds more features to the timeline, but it keeps things a bit cleaner up here. We've got the airbox and we've got our starting point shape. I'm going to save this again. And for this video, there's just a few more things I want to cover for this basic shape. We also want to basically add this bottom piece, this lip, which is going to get shelled out. There are some additional features that might be needed, and the back is missing here. But what we're going to do is we're going to create a sketch on this face. If we want to, we could use mesh section sketch. Again, we know that what we're doing here is using linear or straight edges instead of slightly curved ones, so it's never going to be perfect. So what I'm going to do is I'm just going to eyeball it. So I'm going to go from basically here, making a vertical line. We're going to come over to here. We'll come back down. These are going to have some sort of taper on it. Going to go straight across and over. Because I don't have a perfect center line here, what I would generally do is, I'm going to hide the mesh for now. And actually, let's hide that body. What I would generally do is double click that, convert it to construction, and then use a line, find the midpoint over here and the midpoint over here, hit escape, make that construction, and then make sure that it's horizontal or the edges are perpendicular. And then I can use this as a midpoint reference down here as well. So find the midpoint, find this midpoint, make this construction. Little kind of a side tip. If I were to make this vertical and then want to make a construction, after you apply a constraint, it automatically deselects whatever entity you had for whatever reason. But if you convert it to construction first, the line still stays selected. So doing things like converting to construction first and then applying a constraint saves you from having a couple of extra clicks. All right, I'm going to bring the airbox back. I'm going to move this up. And the main reason for doing that midpoint thing is because now I can make these two equal. The other thing that we can do is we can add symmetry between them. So if you want to use the symmetry constraint, for example, let's go ahead and select symmetry. I can select this line, and then the symmetry line here. There are already constraints added to them, so that's going to be problematic. So it looks like they're maybe already going to be symmetric just based on the fact that we've got a midpoint relationship here and a midpoint relationship here. But in general, that's the process that I kind of go through. So I'm going to bring this down. Bring this one down. We're going to have a fillet there and a fillet there, a fillet there, and it all looks pretty close. I'm not going to add any dimensions for this example, but hopefully you can go through that process if you want to. So let's extrude this. We are going to eyeball it down to, looks like maybe 11 or 12 millimeters. It's like 11.5. I'm just going to go with 11 for this. And we're going to join it to the original body here. So we're going to say, okay. We're going to bring back the airbox, and we want to add some fillets. So first I'm going to start with these two here. Get them pretty close. Looks like maybe 25 again. Again, remember it's poking out here because it's not a straight line, it's an arc. And for these ones down here, 25 is probably going to be too big. Yeah. So what I'm going to do is I'm going to hit plus, and I'm going to try to add, say, a 10 millimeter radius there. Hold down Control and just add some additional edges. And again, if this is going to be, let's say, 3D printed, it doesn't need to be perfect. You are going to have some tolerances associated with the fact that it's 3D printed, and getting it close enough so that it can work is kind of the goal. All right. At this point in the design, we're not really ready to shell the part out yet, but I do just want to point out one other thing that we can do. So this part has a wall around it. Now, in reality, what would probably happen is this wall would be a sweep around the outside. It's going to be at an angle, again, because draft. We're not going to worry about that. But one thing that we can also do, or we can look at, is using tools like the shell tool. So for example, if I select this face here and I say 3 millimeters thickness, it's going to give me a thin wall part for the entire inside. I think the part's about 3 millimeters thick. If I hold down Control and select additional faces, we're going to need to turn off tangent chain. But if I select, let's say, these faces here, we'll do the same thing over here. Hold down Control. Essentially what this is going to do is it's going to allow me to get rid of that front piece of that wall in the same operation, which is why I decided to do the extrude and build the whole thing like that. Now, as I said, we're not ready to do a shell yet because we still need to, let's hide that, we still need to make this face around the inlet flat. We need to make this face flat, and also this face, we have this little cutout section that we need. All that stuff really should happen before we do a shell. So it is consistent wall thickness. And then all these little pieces that are on the outside. So things like this intake or this inlet, all the ribs, all the attachment features, all of that stuff is going to happen after we have our thin wall part. Because you don't want to do a shell when you've got things like these bosses here. So that's something that you would just do after the fact. But that's going to be the basic approach that we have to create that general shape. So I'm going to roll back before the shell, knowing that we can go back to it later. Let's do a quick save, and I want to leave you with one more tip before we end this video. I know this video is long, I mean we're going to be at 45 minutes, but in reality this stuff isn't fast. It takes time, and there's a lot of design decisions that have to happen along the way to make it work. And again, this design, the intent is 3D printing. It's not an injection molded part. We're not worried about draft, but the last thing I want to leave you with is creating reference planes for things like the mass airflow sensor. We've talked about this before. We've gone into our mesh tools and we can go into Mesh Direct Edit. And when we're in Mesh Direct Edit, we have the ability to create a plane at 3 points. So for example, we need to try to pick planar references on the tops of those, and it says it's not visible because the construction folder is hidden. Don't worry about that. And we can create that plane. I'm going to say finish direct editing. This automatically creates a copy of the mesh, unfortunately, but the plane that we have is going to be pretty close to that top plane. You'll notice that the mounting bosses for, again, I'm assuming it's an airflow sensor, the mounting bosses are a little bit taller, but they should theoretically be parallel, so we could use that same plane for those and kind of extrude them. The problem that we have with this method is when we go to create a sketch on that plane, this is going to be the inherent issue. The coordinate system is shifted. And when you first look at this, you might think the entire part shifted, but if you look at the view cube up in the top right, you'll see that the default or the normal origin is rotated, but our sketch origin is based on the orientation of the 3 points we selected. So because of that, that can be kind of tricky, especially when you're trying to make something like this rib here that should be in line with this, which technically should be in the x-axis. So what I'm going to do is delete that sketch, delete the direct edit, which will get rid of that plane because it's all part of that. And the other method I want to show you is we're going to use a mesh section sketch for this. Again, select the body here. The plane is going to be this plane. And it actually works out because it's right in that rib based on the references I used when I aligned this in Quick Surface. We're going to say OK. From here, what we're going to do is find that sketch, edit, and let's hide the mesh. Let's hide the solid body. So essentially what we have now is a reference here. So we can go and extract or fit curves. I can select a point here and a point on this one. And then we could say, OK. So now what we have is a reference line based on that mesh. And we can create a plane at an angle by selecting this and just making it 90 degrees. And the reason for this is because we know, at least for this part, that the mesh orientation is going to be based on how I set it up in Quick Surface, aligned to the coordinate system, which is going to be based on things like a reference edge on the part. And then we can just make that plane at 90 degrees to that because we know, again, it's kind of in line with the XZ plane, essentially. And so now if we select this and we create a sketch, what we should see is the coordinate system for the sketch is aligned to an XY, a known XY, right? So if I take a line and I go from the origin and I come out here, that is going to be, or should be, directly in the middle of that rib there. So if we wanted to create a reference for things like this feature, doing the sort of picking 3 points to create a plane is a good option and an option I use when I'm trying to align a part to a coordinate system in Fusion, even though that's, it's kind of a finicky thing to do. But anytime that I have something where I need to create a reference plane, creating a 2D sketch like that and then doing a rotation about that 2D sketch can be pretty helpful. And you don't have to do a mesh section sketch. It's going to be more accurate if you do, but for example, if I draw a line, let's go ahead and just draw this line here. And again, there's a slight curve to this because it's injection molded and because of, the part may be very slightly warped or curved just from use. Now I can make a plane 90 degrees around that. And what this should give me, let's go ahead and hide that sketch. What this should give me is a plane where it's aligned to the coordinate system. So you can see that X should be in the center of this. And then I can do a circle here. It's going to be kind of hard to see, but let's go ahead and just drag it a little bit to the left. And we'll make that construction. All right, so if I extrude this, what we should see is that that's a pretty good representation of that geometry, right? And if we're I'm gonna go ahead and join that together, right? So if we're gonna be adding that feature there, and let's say that we go ahead and we do the shell, and I select that face, that will give me that feature added to the part, and the shell will allow it to go all the way through. Now, in reality, I think that wall is actually a little bit thinner than 3 millimeters, but in general, so hopefully that makes sense. Doing those reference edges, whether it's with a mesh section sketch or whether you just kind of eyeball it, and then you create a plane 90 degrees to that. So you take something like the XZ plane and you rotate it 90 degrees to get your geometry. Now, if it's not 90 degrees, then that workflow falls apart a little bit. But in many cases, that can be a very good option for creating that geometry. Now, for us, we're not quite ready for that. I'm going to delete that feature. I'm probably going to leave that sketch because we're going to use that in the next one. We're going to use that, but we need to create a flat spot there first. So if I hide the solid body, you can see there's that sort of recess there. So we're not quite ready to add that geometry yet, but hopefully that makes sense. So in the next video, when we carry this on, I will provide a data set with everything that we've done in this video. If you happen to have problems, you can start with the one that we provide. But now that we understand the nuance or the basics and the nuances of making some of these design decisions and creating the basic rough shape and making tweaks and adjustments to get it closer to that original body, the next one we'll start to talk more about adding details. So we'll make that recess, sort of the flat spots that we need. We'll make This cutaway back here, we'll look at ways that we can do this fairly easily. And then we'll talk about adding features like support ribs and things like that that are really injection molded features for a 3D print. We can get away with doing a chamfer and doing some fillets. Simply because if you do a 3D print, you can do infill. So if you, let's say this is a 3mm thick part, and you have it set up so that you have a certain number of walls so that you have 3mm of solid, then areas where it's thicker, like in the corner, if we just do a chamfer, we can just have infill in that area and it's not going to be solid. Whereas these kinds of features take a lot more effort to 3D print, and they're not really going to be that strong just based on the print orientation, where a large chamfer is probably a better option for a 3D printed part. So we'll talk a little bit about that in the next episode. But if you have any questions or comments on what we've done here yet, then please leave it on this video. If you want to see more, consider subscribing to the channel, and hopefully you can follow along in the next episode or two and we can finish off this part. So once again, thanks for watching, and we'll see you in the next one.